Welcome back. Today we are going to be talking about how to solve this question here and walking through it. This question has to do with the future value equation and annuities specifically. So let's dive in. Matt wants to save money for his retirement. He gets paid monthly and decides to invest $1,000 a month into his retirement, which he expects will average a 7% return annually, compounded monthly. He plans to retire 35 years from now. How much will he have from this retirement savings plan in 35 years? Okay, so let's first discuss why wouldn't we just use the regular future value equation? Well, just the regular future value equation assumes that we put in a certain amount of money up front. So maybe instead of paying $1,000 a month for 35 years, he'd pay $12,000 a year, which is what he's paying for 35 years. And he does that and he puts that money all in right now. But that's not what's happening here. He's not putting all the money into the account right now. He's going to be continually every month adding an extra 1,000, adding another 1,000, adding another 1,000. So the first 1,000 is going to have a lot of time to compound. It's going to have 35 years of time to compound, basically. A few years in, that money's going to have a bit less time to compound and less time to compound. But and by the end, when he's putting in $1,000, he'll almost immediately just take out the same thing for retirement. It'll barely have any time to compound at all. And so some of the money from his earlier years, is actually going to have a lot more time to compound than the money he puts in the later years. And so it's not all going to just compound the same rate, because the longer the money is there compounding, the more of an impact it has, the larger it grows. And so that's where annuities come in. And that's why we need to use this future value equation instead, which specifically takes into account what happens when we continually put a certain amount aside. And this is more realistic for a lot of people. Oftentimes, we're not just going to have some big windfall of hundreds of thousands of dollars coming on to us, or even tens of thousands of dollars. However, maybe we can make a realistic plan for setting aside a certain amount each check, or a certain amount aside each month, and invest that. That could be a much more realistic strategy for the average person. So let's write down the future value equation for annuities specifically. Future value is equal to A times 1 plus I to the power n minus 1 over I. And A is the cash flow. N is the number of compounding periods. I is the interest rate per compounding period. All right, so in this scenario, Matt's cash flow is going to be $1,000 because every month he puts in $1,000. N is the number of compounding periods. Well, if this gets compounded monthly, and yeah, this gets compounded monthly, and he's going to do this for 35 years, so 12 compounding periods per year times 35 years. Let's see what that gives us. 12 times 35 is 420, so overall there's 420. And then I is the interest rate per period. So the interest rate per year is 7%. So that means if we divide that by 12, we can get the interest rate per period. And that is going to be 0.00583 repeating. And so now all we need to do is put this into this equation, and we can figure out how much money Matt is going to have. So the future value is equal to 1,000 times 1 plus 0.00583 repeating to the power of 420 minus 1 all over 0.00583 repeating. Okay, so let's see what that is. So first I'm going to punch in 1.00583 repeating to the power of 420 equals minus 1 equals divided by 0.00583 repeating equals, and then last but not least, times 1,000 equals, and I get 1,801,000 $54.43. So that is pretty incredible. By putting aside $1,000 a month at this rate, he will have almost $2 million just from this retirement savings plan, which that's pretty good. Because if you consider how much did he actually put into this plan? Well, he was setting aside $12,000 per year for 35 years. So the actual money that he put into this was $420,000. And he ended up, because of the power of compound interest and doing this consistently, especially from such a younger age, he ended up with 1.8 million. So that's pretty good. As always, if there's any questions, please leave those in the comment section, and we'll see you for the next one.